Hi students, welcome to section 9.2, L'Hopital's rule. This is found on your textbook, page 448. It goes all the way until page 454. In this lesson, we are going to learn about how to determine limits of indeterminate forms of 0 over 0, infinity over infinity, infinity times 0, infinity minus infinity, and we'll also be looking at the limits of indeterminate forms of the type 1 the power of infinity, 0 the power of 0, and infinity the power of 0. Now let's see the first form of the indeterminates, which is 0 over 0 form. If a function f of x and g of x are both 0 at x equal to a, then limit of f of x over g of x cannot be found by substituting x equal to a. The substitution produces 0 over 0, which is the meaningless expression known as indeterminate form. All right, so how does the L'Hopital's rule help us find the limits of these indeterminate forms? Suppose that f of a is equal to g of a and both of them are equal to 0. And given that f prime of a and g prime of a both exist and that g prime of a is also different from 0, then the limit of f of x over g of x as x approaches a is equal to f prime of a divided by g prime of a. This is the simplest form of L'Hopital's rule. Now let's start with the first example of our lesson. Use L'Hopital's rule to find the limit of square root of 4 plus x minus 2 divided by x as x approaches 0. If we plug in 0 here, it gives us an indeterminate form of the type 0 over 0. Therefore, we have to apply the L'Hopital's rule. To do that, we have to differentiate both numerator function and the denominator function. If we differentiate the numerator function, it gives us half into 4 plus x to the power of minus half, and the g prime of x is equal to 1 for the denominator function. Now we have to continue finding the limit of these newly differentiated functions as x approaches 0. Doing that, we get the derivative of the numerator function is half into 4 plus x to the power of minus half. The derivative of the numerator function is 1. If we plug in 0 now, 4 plus 0 is 4. 4 to the power of minus half is 1 over 2. 1 over 2 times 1 over 2 divided by 1 gives us 1 over 4, which is a real number. Let's have a look at the second example of our lesson. Evaluate using L'Hopital's rule. Find the limit of sine x divided by 2x as x approaches 0 from the left. Let's substitute x equal to 0 in both the numerator function and the denominator function. Sine of 0 in the numerator gives us 0, and 2 times 0 in the denominator also gives us 0. So it's an indeterminate form of the type 0 over 0. Therefore, we have to apply the L'Hopital's rule that says differentiate both the numerator and the denominator and find the limit of the new derivative as x approaches 0. So the derivative of sine x is cos x, of 2x is 2, and if we find the limit of this new cos x over 2 as x goes to 0, cosine of 0 is 1. 1 divided by 2 is our new limit. Example 3. This time let us see the indeterminate form infinity over infinity. Identify the indeterminate form and evaluate the limit using the L'Hopital's rule for the limit of cosec x divided by 1 plus cot x as x approaches pi. If you closely look into the graphs of cosec x and cot x, both of them have a vertical asymptote at x equal to pi. Take note that cosec x is the reciprocal function for sine x, and cot x is the reciprocal function for tangent of x. So both of them have got a vertical asymptote at x equal to pi. And in particular, at x gets closer to pi, cosec x goes to infinity, and 1 plus cot x also goes to infinity. That is not a number. It's infinity over infinity is not a number, it's an indeterminate. Therefore, we have to apply the L'Hopital's rule that advises us to differentiate the numerator and the denominator separately and find the limit of the new ratio, cosec, the derivative of cosec x over 1 plus cos x, and find the limit as x approaches pi for the new derivative. The derivative of cosec x, I hope you remember, it is minus cosec x times cot x, and the derivative of 1 plus cot x in the denominator is, the derivative of 1 is 0, and the derivative of cot x is minus cosec squared x. And if we simplify this one of the cosecs will go from the denominator, will cancel out, and you will have a limit of cot x over cosec x, which simplifies to limit of cos x only as x approaches pi, which is minus 1. And this is a real number. So the right-hand limit is also equal to minus 1. Therefore, the two-sided limit is equal to minus 1. Here, we observe that when the numerator and the denominators are going to infinity, as we substitute x equal to a or pi in our case, and we get an indeterminate form of the type infinity over infinity, we can use the L'Hopital's rule to differentiate the numerator and the denominator separately and find the limit of the new derivative or differentiated function at x equal to pi. That gives us minus 1. Let's see the next example. That is an infinity times 0 type of indeterminate form. Find the limit of 2x times sine of 1 over x. If we plug in this very big infinite number in place of 2x, it gives us infinite, obviously. And if we plug in a big number in 1 over x, it goes close to 0, and sine of 0 is 0, we know that. So it gives us an infinity times 0 form of indeterminate. Hence, we need to apply our L'Hopital's rule. To make our work easier, let's assign a new variable h for 1 over x, so that it becomes a sine h only. This gives us limit of 2x times sine of 1 over x is equal to limit of 2 over h times sine of h as h goes to 0. Take note at the beginning, when we say h is equal to 1 over x, as x goes to infinity, as given in the first limit, when x goes to infinity, 1 over x goes to 0. So h is going to 0. So the last limit becomes limit of 2 times sine of h over h as h goes to 0. And you remember from our limit lessons at the beginning of this academic year, the limit of sine h over h as h goes to 0 is 1. Therefore, 2 times 1 simply gives us 2. Now let's see the other indeterminate forms. 1 the power of infinity, 0 the power of 0, and infinity the power of 0. Here we will be using the natural logarithm to help us find the limits of this type of indeterminate. The limit of ln of f of x as x approaches a is equal to L imply the limit of f of x as x approaches a is equal to limit of e the power of ln of f of x as x approaches a. This is exactly the same as saying raising ln of f of x is equal to L to the base e on each side. And then this gives us e the power of L. Here, a can be finite or infinite. Okay, now let's see another indeterminate form of the type 1, the power of infinity. Find the limit of 1 plus 1 over x, the power of x, as x goes to infinity. If we plug in a very large number, which is here symbolized by the symbol infinity, 1 over x or 1 over very large number is close to 0. So 1 plus that very small number is simply 1. And 1 the power of x becomes 1 the power of very large number, or 1 the power of infinity. Therefore, this is an indeterminate form which we cannot determine how big 1 the power of infinity is. So let's assign f of x is equal to 1 plus 1 over x the power of x. Next, take the natural logarithm on each side. Ln of f of x is equal to ln of 1 plus 1 over x the power of x. This helps us to get down the x in the exponent to the coefficient by one of the rules of logarithm. Again, in our next step, the x in the coefficient can be written as a denominator of ln of 1 plus 1 over x, but taking the reciprocal 1 over x. Now let's try to plug in that infinity, which is a very large number, in place of x. This gives us an indeterminate form of 0 over 0 type. How? In the numerator, if we plug in 1 over infinity is 0, and 1 plus 0 is 1, and ln of 1 is 0. You know this one. Logarithm of 1 is 0. In the denominator, 1 over infinity is 1 over a very large number, which is 0. So it gives us 0 over 0 type. Therefore, we have to apply the L'Hopital's rule by differentiating both numerator and the denominator. What happens if we differentiate ln of 1 plus 1 over x and the denominator 1 over x? The numerator differentiates to give you 1 over 1 plus 1 over x times the derivative of 1 plus 1 over x by the chain rule. So the derivative of 1 plus 1 over x is simply minus 1 over x squared, because the derivative of 1 is 0. And in the denominator, the derivative of 1 over x is minus 1 over x squared. And minus 1 over x squared cancel out both from numerator and the denominator. And finally, you end up with limit of 1 over 1 plus 1 over x as x goes to infinity. Now you'll not have any trouble plugging in infinity in place of x. That gives you 1 over 1 plus 0. That simply results in 1. We are not yet done. This is ln of f of x. So to get our final answer, we have to raise e the power of ln of f of x, which we already found. E the power of 1 is equal to e. Hence, the limit of 1 plus 1 over x, the power of x, as x goes to infinity, is equal to e. Let's work on another example that involves 0 the power of 0 form of indeterminate. Find the limit of x the power of x as x goes to 0 from the right side. If we plug in 0 here, it gives us 0 the power of 0, which is an indeterminate form. So we have to use the L'Hopital's rule, where we can make use of the natural logarithm ln x. If we assign f of x is equal to x the power of x, and then we take ln of each side, we have ln of f of x is equal to ln of x the power of x. This helps us to get down the x in the exponent to the coefficient of the natural logarithm. Again, x times ln of x is exactly the same as ln of x divided by 1 over x. Apply L'Hopital's rule to this one, to limit of ln of f of x as x goes to 0, which is limit of ln x divided by 1 over x. Now we have to differentiate ln of x and 1 over x. Both the numerator and the denominator should be differentiated by L'Hopital's rule. The derivative of ln x is 1 over x, and the derivative of 1 over x in the denominator is negative 1 over x squared. If we simplify this one, we simply get minus x, and the limit of minus x as x goes to 0 is 0. But to conclude our answer, we have to raise 0 to the power of e to find the limit of x, the power of x, as x goes to 0. So e the power of 0 is equal to 1. Hence, limit of x, the power of x, as x goes to 0 is equal to 1. Okay, here are 2 quiz questions for you to try from section 9.2. You should solve the following problems without using graphing calculator. Which of the following gives the value of the limit of x plus 1 the power of 4 third minus 4 third times x minus 1 divided by x squared as x goes to 0? Try to plug in x equal to 0 in both the numerator and the denominator function, and identify which of the indeterminate form it is, and then apply the L'Hopital's rule and try to identify which one of these 5 choices gives you the correct answer. Here is another quiz for you to try. which of the following give the value of the limit of 3x to the power of 2x as x goes to 0 from the right side? You have got 5 multiple choice here. One of them contains the correct answer. Identify which of the indeterminate form it is and try to get your answer. Okay, with this we come to the end of the lesson. I hope you have got a good understanding on the topic. See you on our next video of week number 16.